We want things to be available from every machine. We want things to have real-time collaboration. We want people to be able to share a link and get up to speed. We want you to be able to decide, am I going to upgrade? And most importantly, if someone can take something away from you, it's not really yours.
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey, everyone. We're really excited to have Peter joining us. Peter, you run, or PVH, as folks may know you online, you run the Ink and Switch Lab. You have helped coin the Local First paper. I see you a lot at the Local First conferences. I'm so excited to have you on the podcast to chat with you about all the things that Ink and Switch is working on. And in particular, we are going to talk about Automerge today. But before we dive into that, would you like to tell our listeners a little bit more about yourself?
Yeah, sure. Let's see. I work as the director of a research lab today, but my background is pretty wide-ranging. I like to say I move like a knight through the industry, like jumping up and landing in weird, unexpected places. I've worked in Arctic oceanography as a research support programmer. I've done game development. I wrote a physics engine for the Game Boy DS using fixed point math. That was a fun challenge. I worked doing desktop software, building Songbird, which is like a media player. I think I at one point broke a lot of people's ID3 tags because I shipped a bad release of taglib. And what else have I done? Then I was at Heroku, which is a platform as a service in the Ruby on Rails era. And that was a ton of fun. We scaled from like nothing to very big. And then I got out while the getting was good and joined this weird research lab. And we've been doing local first software ever since, among all these other things. And sometimes I joke that like my research is like atonement for having built the cloud, right? It's like we built the cloud and then we realized what was wrong with that. And I was like, oh no, like now I'm trying to fix the problems I helped to create, which is maybe the classic like mistake people make, but hey, we're doing it.
Yeah, about that. In 2019, you had this big, nice, long blog post about local first software. How did you get to that point? And like, where did it start where you're like, okay, local first might be the shift that we need in software? Did it start there at Heroku?
I often tell the story of, I was on a train, the end of Judah in San Francisco, coming from like Ashburn, where I lived at the time, into town. And if you've ever been to San Francisco and taken the NJ, it's above ground sometimes, then below ground, and then above ground. So it goes in and out of the tunnels. And I was listening to music on RDO, which was like it was a competitor to Spotify at the time that had some friends who worked at. And whenever it went in the tunnel, like I'd lose reception and then I'd want to listen to this. So I'd have to put my phone into offline mode. But offline mode had like radically different bugs and features than online mode. And it was like a gong went. This is a little bit of recreating, the Eureka moment, I think is an expectation of this. But it is definitely the case that I had this feeling that something was wrong. And I had this feeling that, like, why could I not browse my playlists offline that I was literally just looking at? You flip it into offline mode and the song you were listening to stops and the playlist you were looking at disappeared. And the reason was like really obvious if you're a software developer in the modern world is like that data was all in the cloud. And like the version that was cached and downloaded was like a separate code path, right? And it was a separate sync system and all this kind of stuff. And I just had this like really uncomfortable feeling that like we were doing something really structurally problematic. And a lot of other events reinforced that over time. At Heroku, we basically gave away millions of apps to people. And because we could do it for cheap, because we had this sort of dyno thing that would start and stop your app. And this sort of modern functions as a service is a similar equivalent using the technology of the day. But at some point, those apps, there were too many of them, and our corporate overlords wanted to like cut costs. And all of this software that we'd worked so hard to keep running for years started to just disappear from the internet. And my colleague at Ink and Switch and our designer at Heroku, Todd Matthews, had this like recipe for making eggnog. And as we record this, it's like the time of year where you might be making eggnog. And it was just eggnog.heroku.com for a long time, but it's not there anymore. It's gone. But it's still there on his GitHub profile. So I can read the source code to the eggnog recipe. But I can no longer see the recipe the way he presented it because it runs on some ancient Ruby stack. And like this combination of like, why don't things work offline? But also like, why are the things that I care about falling off the internet and disappearing? Those two things combined in my head and made me really start to question like the software architecture and the whole kind of approach and philosophy that we have about building software.
Was the sort of like lead up to the lab, like going from sold Heroku, you have some time and space and money to sort of like reevaluate what's important. Was the lead up those like things that had been building up over time of like these like software experiences or whatever, or did you just like see an opening in the industry where you're like, we don't have like a modern Bell Labs, the same like group as it existed. I mean, there is a modern Bell Labs, but the Xerox PARC of.
We didn't have that kind of ambition or arrogance. I would never dream of trying to start a modern Bell Labs. I mean, kudos to anybody who has that spot for that. The actual story is I'm not a Heroku founder. I was an early employee and joined near the beginning. That was the lucky 13th employee, I think. At least that's how I remember it. And after Heroku, the founders of Heroku ended up leaving Salesforce for one reason or another over time. And they got together and they were saying, like, what should we do next? And I love this story because they were basically like, look, society's on the ropes, man. No one trusts the journalists. Science has a reproducibility crisis. Like democratic institutions are in decline. Like around the world, we have ecological crisis. Like all things are rough out there. I think that's absolutely still the case today, if not more. And, but what can we do? We're just software guys, right? Like we're tool makers. We're not physicists or like journalists or whatever else. And so the idea behind Ink and Switch was like, let's get together. We'll spend like 6 months to a year and a half. We'll come up with a theory about how we want to approach this problem. And then we'll start a startup and we'll try and build a thing. And analysis was like, there's a lot of like opportunity because the operating systems of the day are not in great shape in terms of supporting the needs of creators. Apple is more interested in like making sure you can get your Netflix than being the preferred platform for Photoshop. Microsoft is like some kind of funhouse carnival of you click on the start button to open an app and you see some news with Donald Trump's face talking about something. Like that is not conducive to like deep thought. And Linux, maybe next year is the year of Linux on the desktop, but it's not this year. And so it felt like there was this gap in the computing ecosystem where nobody was actually incentivized to think about scientists, to think about journalists, to think about the people who we need to solve these problems. And so the theory was that like Ink and Switch could try and figure that out. Now, I joined about a year into that effort, or maybe a little longer in that ballpark. And then we spent a year trying to figure things out. And it turned out that the problem was a lot harder than we expected. Classic kind of thing. And in fact, yeah, Adam did spin out Muse from Ink and Switch was a great Apple tool. But if you compare the kind of like ambition of Ink and Switch and the large to like what we were able to attack with Muse in that spin out with Adam and Mark Brannigan and Julia Rogetz and Leonard Zabriskie. And it's still going under other Adam's leadership. And like it's out there and it's a great product and you should use it if you need an infinite canvas. Like it's a great ideation system. But it was very much just the smallest part of what we were trying to accomplish. And so it just became clear that the lab was going to have to basically be a permanent institution. And so when Adam spun out to start Muse, it was like we looked around the table at each other and me and the other members of the labs, it was like nobody else was willing to like take up the paperwork. So it fell to me. I've been having to do the paperwork ever since, but I don't think of it as my lab. I think of it as our lab. And I'm just the poor guy who has to like make sure the taxes get filed each year.
Cool. With that, let's set the stage of what Ink and Switch is. Some of our audience might not know what it is. So could you explain to us like what you guys do there and how it's funded?
Yeah. So Ink and Switch is an independent industrial research lab. And our field of study is tools for thought. What that means is that tools for thought are the instruments of intelligence amplification, the original vision of the computer as the bicycle for the mind or the Memex, right? And all this stuff dates back to late stages of World War II, Vannevar Bush's Memex project and so on, and carries through Doug Engelbart and Alan Kay and like all Bonnie Nardi, all these wonderful people's work. And we're trying to carry on that tradition and say in a modern context, within the modern ecosystem, how can we help build tools for thought? What do they have to look like? What kind of tools do we need? Who needs them? How should they make them? And I think the thing that kind of differentiates our work from past efforts is that we are both looking with one eye to the future, but also aware of the broader movement of there is a modern software industry with millions of people working in it, lots of people trying things. And so rather than just saying we're going to invent everything new, we want to be able to invent anything, but we also want to think about like how do we fit into the existing world so we can actually influence it. So when I say industrial research, I mean that like pie in the sky, high concept stuff, like sometimes you got to do it, but that's not what it's about. What we want to do is change the practice of software like as it is built over time. So we look less on a 20-year horizon and more on the 5 to 10 year. And then independent means we're not owned by any corporation. We're not owned by any university. We're not directly funded by any single entity. And our funding comes from a mixture of like private funding from people who care about these problems and want to see the world improved, from government contracts and philanthropic contracts. We work with places like the Endless Foundation, and we're working with the Advanced Research and Invention Agency in the UK, and we've done other partnerships in the past. And also with companies, like we've partnered with Notion, for example, for the Paratext project a number of years ago. And so we kind of have those three planks: private individuals, like philanthropic and public interest money, and private industry. And I really think it's important that we're funded by that broad base, because that means that we're still beholden to industry outcomes, but we're not just some company's think tank. We are able to do weird experimental stuff that might not pay out for a long time with our private funding. And then we have this like public good money that comes from places like the EU government's NLNet grant, which really lets us like have a mandate to do things that are like open source or like public interest. So I love having that spread, but it does lead to a lot of paperwork.
So we talked a little bit at the beginning about local first and moving into that, and the tensions that you were feeling with technology, that you and others were feeling technology, that sort of led to that seminal post on local first and introduced it. So we might just like for our listeners just explain like what local first is and how that plays into the lab's like vision of technology. Yeah, let's actually just start there.
Yeah, so first, full credit, I'm a co-author on that paper. The lead authors were Martin Klettman and Adam Wiggins, and the fourth co-author was Mark McGranagan, all of whom are good friends and longtime collaborators. But yeah, the basic idea behind local first software is your software should run on your computer. It's not really rocket science, right? Like you got a program and it should be on your computer. Now, there are times that doesn't make sense, and we're not saying those don't exist, but the idea behind local first software is like when it would make sense to have the program on your computer, it should be there. Now, that's not controversial, and there's a simple way to do that. I wonder if I have any in this room. I probably have a floppy disk somewhere here in my sort of like archive of old stuff. And that's not what we're suggesting. We're not saying, oh, we want to go back to the old days and have like dial-up modems. No, the idea is we want to have the benefits of the cloud. We want things to like be available from every machine. We want things to have real-time collaboration. We want people to be able to share a link and get up to speed. But we want to pair those benefits with the benefits of more traditional software, which say we want it to run on your computer. We want you to be able to decide, am I going to upgrade? And most importantly, if someone can take something away from you, it's not really yours. So if you've installed a piece of local first software, that means that if that company goes out of business, by golly, it should keep working. And these are, to be clear, ideals that I think many people working in the local first space agree on, but there are very real reasons why, despite those aspirations, we're not all the way there yet in a lot of cases. And I don't want to discourage anyone from pursuing those goals, even if we're not able to reach them entirely. But that's the basic idea. It runs on your computer and it works with other people.
I think a big part here, though, is it's in the name, local first. So it's not like the desktop software like the 90s where you installed it and then it was like local only. It's this new world where it is local first, but you are still connected and it's collaborative. And that poses pretty significant challenges, as you've sort of alluded to. So in this world where you want to feel like you or you want to own your data, you want to have more autonomy over the software that you run, you want it to be available even if you're not available online, but you also want to, share things with friends and family and collaborate with people. Like, how do you bridge that gap? How have y'all been thinking about it?
The short answer is that you move the program and the data to the user's computer. Okay, pretty straightforward. Now, if you've got the program and the data, you just need to figure out how to connect it to other people. All right, now we have what sounds like a simple problem. So really what we've done is taken a problem that was like a complex architectural problem and reduced it to a very simple thing, which is like, how do you synchronize data? Cool. So all we really need is a good sync engine. That's sort of a lie though, right? Because like, actually we need a sync engine and we need a really different way of thinking about software. So like the technical problems are real and they're difficult and they're interesting, but there's also a lot of interesting like socio-technical problems and design questions. And I'll give you a really like simple example, which is, okay, great. So let's imagine that you have Google Docs offline. Okay, yeah, I mean, like you can do that now, right? But if you have Google Docs offline and you work on some, I don't know, spreadsheet on an airplane, then you come back online and somebody else has edited the spreadsheet. Well, what should happen? I can tell you what happens in Google Docs. Last time this happened to me, it popped up an error message that said, your document has diverged too much from the version in the cloud. Click OK to reset all your changes. There was not an option to say no thank you. And all that work got lost. That's obviously not ideal. And I think it's interesting to contrast like that experience to something like any software developer would recognize, which is like working in Git. Right. And so like when I'm working on a patch on my machine, I get it working and then I like do a git push and like now it's available for other people. But until then I can work offline. But like when I go to GitHub, I can't look at the issues. I can't see what I'm supposed to be working on. I can't tell what the plan was because all that stuff is on the web. There are very good reasons why Git is not a good database. Most of those are the reasons that our Automerge open source work exists. But it's telling that there is so much benefit to being in the cloud around collaboration that we're willing to put up with this like weird heterogeneous mix of like local first history preserving data for source code and then this like CRUD app web interface for the like actual coordination work. Like ideally what we want is actually both for both. It's ridiculous. It's ludicrous. It's insane that if I want to pair program with you on a task, I'm going to come on a video chat and we're going to stream the pixels of my screen to you. Doesn't that seem... It's plain text. What are we doing? How is this the way we collaborate as programmers? It's humiliating. Writers can go in Google Docs. They can select text. They can copy paste. They can point at things. They can comment. You want to comment on a patch? You got to go to the browser, select... What is happening? Right? And then meanwhile, the writers look at us with Git and they're like, aside from the fact that you don't want to use Git, no one's dumb enough to want to use Git. It's impossible. But they look at our ability to work in private and they look at our ability to like make revisions without the editor reading over their shoulder and to work from the cab coming back from the place where the news broke and not worry that the CMS is going to lose their data. They want what we have. And we want what they have, but no one has figured out how to allow you to both work offline and collaboratively and bridge that gap. And that fundamentally is what our research in local first software is trying to do.
So that's a great transition into the technology. So Automerge is your guys' solution for this. Can you tell us what Automerge is and like how it works at a high level?
Yeah, sure. So Automerge is a local first sync engine. So what that means is that it's kind of like a database. It's not a database, but it's kind of like a database in that it stores data and you can fetch it. And it's local first. So you store the data on your machine. And then if somebody else wants to see it, you synchronize that to them. How does it work? It's really easy. Whenever you make a change, we just write down what the change is. That's it, right? There's a lot of technical magic that goes into making that work and making it fast, but that's it in a nutshell. So if you're typing on a keyboard, when you press a key, we just make a note of where you were in the document when you pressed it. The rest is all performance optimization. There's a little bit of like finesse here, right? Which is if I'm typing in a place in the document and you're typing in the same place in the document, what should happen? And this is where we start to get into something called CRDTs. Should we talk about CRDTs for a minute?
Yeah, absolutely.
Okay, CRDT is an acronym that stands for conflict-free replicated data type. And there's a great bunch of really cool computer science research around this. And I don't like to lead with it because CRDTs, there's a lot of blog posts out there. It sounds like magic. People get really confused and nervous about all the computer science terminology. But again, it's really simple, right? The idea is that when people make changes to this data structure, no matter what order they make changes in, when you mash it together, you should always get the same result. There's like a really simple way of doing this, right? So imagine that I have a JSON document and you have a JSON document. We both edit the document and then we put it together. We just delete the document and then nobody has any data. That's technically a CRDT, right? Because you guarantee convergence. You do all the work and then you throw it away and everybody has the same result. That's not a very useful CRDT, right? That's the thing. So there's other things we could do, right? Like we could record all the data and then we could merge it together and we could do what Dropbox does, which is just give you 2 copies and let the user figure it out. Like that, I think technically qualifies under the same, you gotta squint a little, but it's technically qualifying the CRDT as well. So really there's 2 problems to building a CRDT. One is figuring out how to represent data that users are collecting at their different locations. And then the other one is how to merge the data to produce some useful output. And there's lots of different approaches to this, right? The early research was really focused on saying, what's the least amount of data you can keep and still converge, right? And really interesting study of that. And other CRDTs out there are focused on that task, which is like, what is the smallest, fastest way to merge together 2 data sets? Our approach is actually the opposite, which is to say, what if Git, but real time, right? So instead of saying, we're going to try and figure out the least amount and throw everything away, but still be able to merge together, we're going to say, we're going to keep everything in really high fidelity and then be able to materialize that into the state that you need quickly. And it's a very different mindset on the problem than most other projects have taken. And it's why we're able to do all of the interesting version control work that is what motivates us. And I don't want to say you can't do these things with other CRDTs. There's a lot of great work out there, but that's our home base and our focus and what our APIs and system are designed around. So does that kind of cover it? There's a lot of like deep technical detail we can get into about how we make things fast, which is really the hard part, and how we make things small so it doesn't take a lot of like memory or disk space to do this.
Yeah, I mean, I think that would be an interesting topic. So you mentioned a lot of folks have put a lot of time into making CRDTs efficient. So it's like either what you're communicating over the wire, which would be important to real time, or like what you're saving on disk. It's especially important if you have like a low resource device. Maybe you have an old Android phone, you like wanting to make software for folks, who have like less modern devices. And some of this would be an issue, but some of it wouldn't be. And so I'm curious, like when you think of Automerge and the sort of use cases you say, yes, absolutely use Automerge for this. This is like our bread and butter. This is what we want you to use it for. And like, here are the use cases where, you know what, this isn't necessarily the thing that we're optimizing for, and maybe figure out a different technology, whatever. Like, what is your sweet spot? Like, where does Automerge like really land well?
Our interest as a research group is in helping scientists, journalists, writers, the kinds of people who we're hoping will solve the many problems that exist in society, right? We want to make their lives better. We want them to work faster, more confidently, be able to more reliably deliver the right answer. So for me, it's more about small group collaboration on creative work. That's home base in terms of our interest and where we put the most engineering in. It turns out there's a lot of adjacencies to that, but like an example of something that would be a great fit is like a code mirror editor for a LaTeX document, or like a to-do list for a project you're working on. And where you might be able to do it, but it might not be a great fit, is where you really want to have scarcity, right? Because the sort of one of the technical consequences, or maybe design consequences of this like local first idea, we always say no one else's computer being unavailable should stop you from working. And so that means it's not a great way to model a bank account, because like actually if the bank is offline, the ATM should stop spitting out money. You know what I mean? Or if you think you're buying a particular seat to a Taylor Swift concert, it'd be real unfortunate if the merge happened and then suddenly you paid the money, but you didn't have the seat you thought you did. So like real time, yes. Collaboration, yes. But like CRDTs are not a natural fit, at least the way we use them for modeling scarcity. Now it is possible, and I could cite some papers, but like there are more obvious ways to solve the problems when what you want to have is like only one of something, even if you can do it on top of a CRDT. So I think the other part of the question was like, how do we make it fast? Is that right?
Yep.
Yeah. So if you think about what I was saying earlier, how does Automerge work? We write down the things that you do and then we replay them. It's not rocket science. But if you imagine what we're writing down like every keystroke that goes into your document, who made it and when. And we're doing it with enough metadata to be able to interleave it with changes from other people. That's a lot of data, right? So a naive implementation, in fact, the earliest versions of Automerge would record like 300, 350 bytes per keystroke of data. So we just naively encode it to a JSON like object and chuck it in IndexedDB, stick it on the disk somewhere. Then we'd replay them all one at a time. Very slow. Very slow. And not only was it slow, it used a lot of memory. So at some point, Martin Kleppmann had this pretty good idea. It was very obvious in retrospect, as good ideas so often are, which was like, you're doing a lot of the same things, right? If you think about this as a database table, what we had was a model where each row encoded all the data of that object. Who wrote it? When did they write it? What operation was it? And we've had this idea that if you rotate that table 90 degrees, and what we do is encode along the columns. This is called a columnar encoding in database literature. I don't know if you guys have database people on here sometimes. But the idea is, hey, look, and actually GIFs work this way. You can say, if you have a run of things that are all from the same author, you can say, look, the next 300 characters, they're all from this one actor. So we don't need to write that down. We just write down this actor ID, and we can say the next 300 are all that same person. Similarly, like we have sequence numbers, which is how we determine the order of things. So we can say, you know what? The default for this column is increment by 1. So we can just say, yeah, there's 300 more entries. They're all just the next one. It doesn't matter. And for text, we can say by default, you insert it right after the last character. So we can actually take the whole string of all those individual characters being typed in and just say, all of these are now represented as just a string in memory. So all the insertion after one place, what you end up with is a record that's spread out across the columns, but it looks a lot more just starting at this time, typed in this whole string. And in fact, that's how other CRDTs would represent it natively, right? But the benefit of our representation is that because we have this run length encoding, you can actually encode a lot of different kinds of runs and different kinds of data in this super efficient way. And the result of all this encoding and careful binary format design and everything else is that on a recent piece that we wrote, we had, I think, 100K of text, real human edited text. And the Automerge document containing all that text with all the provenance, all the version control history, all the timestamps, everything was 140K. I think it was 138 to be exact, because the numbers are in the Automerge blog post, so I apologize if I remember, but I remember it being 38% overhead in terms of disk size. That's pretty good.
Yep, it's pretty solid.
And so the columnar trick is good, but then we had this problem where, okay, we'd store it on disk like that, but then we'd load it in memory and we'd have to spread all these operations out again in order to be able to query them. And then that was really slow. So like our Automerge 3 release was all about working with the columnar format natively in memory, and then also using that to send things over the network. We have a lot of cleverness in the network sync protocol for Automerge as well along the same lines. We use Bloom filters, which are a fun computer science thing that everybody thinks they might want to use, and then nobody ever does. And actually the next version of Automerge will not use Bloom filters again. We found a way that's simpler and faster. It turns out calculating is expensive for large documents, but yeah, over the years, we've climbed up the ranks of performance, right? From the very first prototypes we did 8 years ago now, it was like if you had 1,000 operations, like your Electron app would start running out of memory and crashing and start to get n-squared performance problems and your laptop fans would spin. And this morning, before my first morning meeting, I popped into the Automerge Discord channel. And someone was like, I have this document that's taking 12 seconds to load. Is that surprising? And I was like, okay, let's look at the stats here. And they had 10 million operations in their document. And I was like, oh, are you maybe replacing the entire document on every keystroke? And this is Jevon's paradox, right? Which is you give people more performance and they'll just use it up and come back and tell you that there's a problem. There's probably some way to manage that. But yeah, we now are very comfortable in the millions of operations to tens of millions of operations in a document. Though no matter what system you pick, if you abuse it hard enough, it will start to slow down. And Orion, Henry, and Alex Good, our lead maintainers, they love getting performance bugs, and Orion's whole jam is just like taking a gnarly performance bug and flame graphing it out and then fixing the problem in the Rust code by writing new kinds of like indexes and optimizations. That's as far as I can tell, that's his favorite thing in the world.
It's good to have that kind of person working in your project.
We would not be here without him.
There are a lot of other challenges. So this sort of solves the like collaboration and storage persistence, like, how do we work on something locally and like sync it across? But when we think about like all the responsibilities that a cloud service normally handles, like one of the big ones is auth, right? Like who has access to see my data or this data, or like, maybe I have kind of a complex document and somebody can see pieces of it and other people can see other pieces of it. And I know y'all have done some really great work on this project called Key Hive. And I would love to maybe talk a little bit more about that.
Yeah, absolutely. And you should have Brooke Zelenka come on and talk about this once this thing ships, because it is such a cool project and it is so interesting and exciting. Historically, our answer has been like, auth? Yeah, you could figure that out, right? And like, look, man, we give you the database. You got to just put some auth in front of it, which is a total cop-out. And the truth is, as a research lab, we just don't tell anyone the URL of the documents, and that's okay. We run our own sync server. And people have done great things in sort of traditional ways, which I guess actually it is pretty straightforward. Like you have a web API, a request comes in for a document, you look at the ID they're requesting, you check some table to see if that user can have the data, and then if so, you give it to them. If they try to send you a new version of the document, you do the same thing. If they're not allowed, you say no, you hang up. Like it's standard web stuff. Brooke's big idea with Key Hive was, I love the way she describes it, which is like every piece of data has a little backpack with its auth included. And right now with Automerge, what we do is we say on the server, we unpack the data and we load it into memory as a CRDT, and we say, okay, what data do you have? Okay, what data do I have? All right, let's figure out the diff between those, and I'll send you just the bits you need. And then you do perimeter authentication. So you say, is this user cool to fetch this data? And the idea behind a local first auth, again, let's go back to the original idea. No one else's computer being offline should make your data unavailable. So if that's true, you need to be able to change the sharing rules offline. And if you and me are collaborating like over a Bluetooth connection on an airplane or, via carrier pigeon or whatever, the system should still work, right? Like why should some central server decide who has access? So the idea behind Key Hive is that when you make data, you write down who should have access in terms of public keys. And then we use an extension of the Signal protocol, similar to MLS, which we've decentralized to remove the central server requirement, to be able to encrypt all this data in ways where anyone who has the right key will be able to get the decryption key and get the contents of the documents. And anyone who doesn't have a public key that's associated with the group will not. And so the whole system now goes from, we have to have this central server that decides who can get in and who can't, data as place, to this model where the auth becomes a thing that travels with the data. And all the server has to do is if someone dials up and asks for a copy of the data, which they can't read because it's encrypted, they look and they check the certificate and say, is this user able to demonstrate that I should send them a copy of this data? And if the server says, yep, like I can see from your pub key that, there is a pub key somewhere in the hierarchy of this system that should be allowed to fetch that. Cool, I'll give you the bits. They're still encrypted. The sync server doesn't know, right? Like I can sync data with you that I can't read because I can tell by looking at your pub key, is this person allowed to have access to this sort of like topic, even if I don't know what it's about? And that's really cool. Definitely some inspiration from other projects here. The Secure Scuttlebutt project, which the sort of vision there was like, imagine a bunch of sailors with peer-to-peer networks, and it's like you pull into the anchorage and you like fetch and exchange data from each other, all the like social messages and private messages, but they're all encrypted. And so you're carrying mail for other people, and then you sail to the next anchorage and you swap with other people. And now everybody who you have become the inadvertent carrier of messages for some other people at the next anchorage, where they can decrypt those that you couldn't, but you trusted the sender enough to be willing to carry the bits for them. And that's the kind of definitely an inspiration in the design of the system.
Cool. So a slightly different topic. So Automerge enables this like infinite Git history, but it only seems it's focused on JSON objects and their values mainly. On the website, on your Ink and Switch website, you explore universal version control, which is version control for things outside of that, like images, video, 3D models. Have you guys like gone into any projects on that are notable?
Totally. It's amazing what you can encode in JSON. That's the starting position, right? So step one, what if you just put it into JSON? A64 encode it. What could possibly go wrong? A lot can go wrong. Now, we are working on a project with the Endless Foundation to bring real-time collaboration with branching kind of patchwork-style version control to the Godot game development engine. So that's like an active work. We've got 2.5 people working on it today, right now. It's an open source thing, Godot and Patchwork. And people are using it in classrooms, and we're hoping to mature it to the point where like community members with small teams can just grab it and work on it. And that's a good field trial for these ideas. I think diffing of binary files is hard in like very fundamental ways. Our current strategy for things like 3D modeling is to diff, and it doesn't necessarily, it's what we call JSON is a lie, really. It's more like POJO. They're just like JavaScript values. And so the way we're approaching this for like 3D modeling is to say, use like USDJ, which is the JSON version of the USD Universal Scene Description format. And then we can load that and put that in. It's interesting. I think about, forgive the digression here, I think about the size of a document as being like a 3-dimensional rectangle shape, like a rectangular prism. What's there a name for that? It's not a cube. A rectangle cube. Whatever. But I think of how many changes there are to the file as being its depth, right? So if you just had a counter that flipped between true and false every second and you ran that thing for 10 years, you'd have a lot of values, but you have a very narrow document and a very short document. A cuboid. Yes, great. Cuboid. I love it. If you had a very deep history, you might have a very small document, but it's very deep history. And that has certain challenges. The nice thing with a document like that is like, if you can figure out how, you could just get the current value and you don't need the rest. It can be very small, 1 bit. There are also documents that are like very wide, and like a scene graph for a 3D scene is one of these. There could be millions or tens of millions of individual keys, right? Lots of triangles and paths and everything else. And so those are challenging in a different way because you just have a lot of stuff to like manage. And then there are documents that are tall. And so like a good example there would be like if you put a perfectly legal Linux ISO that you wanted to watch into an Automerge value, and then you wanted to like stream parts of that Linux ISO so that you could watch it on your device, that's like a very tall value. And we just punt on that because you can watch your Linux ISOs with other existing solutions. But on some level, like it's useful. And it's the old joke about like databases, don't put JPEGs in your database, but everybody does, right? And so we have a certain amount of support for just having binary data in Automerge documents. And in fact, the way we model this in our sort of lab system that uses Automerge is we just have a file document, which is like a static object that has a binary array of data in it that doesn't change. Could it change? Sure. Will that probably break if you merge? Absolutely. Maybe you're clever and you can do it in a way where it will work. That's above my pay grade to figure that out. I don't know. People say AI at this point and wave their hands and nod politely, and we move on to another topic.
Yeah, so there's like some intent, that's like not captured in the binary output of something, and some question about like, could you like have a binary file and then layer on some like metadata on top,
Great example, right, is in music and movies. What you have are called stems. Those are your unchanging things. So the way I think about how to build apps in this ecosystem around that is you have data at the bottom that's like binary data that doesn't change, or when it changes like as a unit. But if you recorded a video of an actor through a camera on a day, that's just how it is, right? The ultimate video that you like look at through your Linux ISO, like it's going to go through a lot of transformations to get from point A to point B. And I think of each of those as being like, I think of changes in Automerge as being deltas, right? Oh, this value goes from A to B, this value goes from C to D. I think of that kind of way of working as lambdas. You have these stems and then you run some code that produces a new version. Then you run some code that produces a new version. Like Photoshop layers have a very similar vibe. And so I think if I were going to build a local first native like image editor or video mixer, I would build it up on this foundation of stems that are either unchanging or low flux, and then almost like a build system that compiles them up into the eventual like final product. And if you're interested in reading more about that, we did do a paper on this where we explored some of these ideas through the lens of like scientific writing and astronomy, and that's the Jacquard paper on our website, inkinswitch.com/Jacquard.
Nice, awesome. Yeah, for folks who haven't went to the Ink and Switch website, you definitely should. There's so many good papers, so much good research there. So to help people get a fuller understanding of Automerge and like how it works under the hood, we've talked about CRDTs a little bit, but like how would you compare and contrast like Automerge to a traditional database?
So in a traditional database, you have a table of things that can change over time, right? The current, are we going for lunch, for tacos or pizza? You would use SQL and call update and replace the value. And then there's this whole idea called ACID, right? Atomic, durable, whatever. You can look it up on the Wikipedia page if you need to know. I'm past all that now. We're into calm land. And its consistency is logical monotonicity. And so the idea is that instead of being ACID, you're calm. And so when you want to make a change in a normal database, you have to grab a lock and you make an edit and then you return the lock. And there's lots of view serialization code. And I come from like Postgres land personally in my engineering background. And so there's a lot of effort that goes into making sure that things happen in a single order. But if you're doing things on different computers and someone might be offline, you don't have that option. So the idea behind this like logical monotonicity is monotone means always increasing or never decreasing in the computer science literature. And so what happens is over time, if you want to change that value, what you do is you say, I'm replacing this value. I'm adding a new value at a new point in time, because you can't change the past, right? So you're introducing a new thing. And so the idea behind this kind of Automerge view of data is that rather than saying I'm editing the document, you say I'm proposing a new value for the document at this point in time. And that means that at any point in time, you can go back to earlier versions and you can actually rewind history and say, what did the document look like at this point in time? And because you have this sort of like distributed system thing, what we do is we use something called, similar to a Lamport clock. Leslie Lamport is a distributed systems writer, maybe still is. I'm not sure if he's retired or not. But Lamport clocks basically say, this thing happened not at this time on the wall clock, because you can never get two laptops to agree on a point in time. What you do is you say, this thing happened after that thing. So I don't know if we should get, from the computer science perspective, I don't know if we should get pizza or tacos. But if you said we should get tacos, and then I said, I saw that and I think we should get pizza, that means something very different than if we both propose those things simultaneously. And so a Lamport clock lets us order things logically so that when you have conflicting values, you can detect it, because what you're doing is you're always saying, I've seen this and now I'm adding that, regardless of what the time on your laptop says. And so that's the core idea behind building up like an offset-based CRDT, is that rather than replacing data, you're just adding new data. You can never undo what's been done. Time just grows, man.
So look into the future, which we love to do. It's 5 years since that local first episode. It's 5 years since that local first essay. Where do you think the movement has been a movement, and where do you think it goes from here?
Oh, it's 5 years. That's great. Bill Gates famously said, people always overestimate what they can do in 1 year and underestimate what they can do in 10. So almost 10 years ago now, we started doing this work and said, the world could be different. Computers could work in different ways. We could have a group of people, a community of people who are building technology, who are taking their time, who are dedicated to solving problems that will really help not just advance distributed systems, but specifically advance science and communication, collaboration, and help us be smarter both as individuals and as a society. And when I see the progress that we've made, the fact that there's a local first conf and SyncConf and this community of people around the world in Europe and North America and other places all around the world that are talking about these issues, I mean, that just gives me so much hope about where we're going and so much excitement about how much progress we've made. But I think these are just the opening moves. I think local first software, like, it's an important technological step, right? The ability to have privacy is huge. The ability to work offline. And remember, offline doesn't necessarily mean that your Wi-Fi is off. It might just be like when you're working in Git, where it's actually, I just want to be left alone. Like, I need to type in this text buffer by myself and not have anybody else typing in here. I'm trying to write some software, or have my LLM write me some software or whatever, right? Like, it's about creating pools of progress and then being able to bring things back together rather than all being slammed together all the time. But that's the beginning, right? Once you have that, great. Now we can do the interesting work, which is starting to say, so why is there only one copy of Discord? Why can't I add features to Discord? Why is it that I can check source code into Git, but I can't check my TL drawings into Git? Why can't I version my figures? Why can't I share other kinds of media, my Photoshops, right, and version on that? And there have been small point-wise attempts to solve these problems. But the issue is that before we had these kinds of like local first foundational technologies, everybody had to invent that whole stack underneath them for each app that wanted to do this. And so my hope is that 5 years from now, we're all taking local first for granted. I hope we don't talk about CRDTs at all. I hope there's a thriving community of people who are like in love with these things and who are spending their time eking out like fractional improvements with the L1 cache for whatever microcontrollers. Great. But I hope that most people just ignore it, the same way we don't think about how WebRTC works or how batteries get charged. I want to live in a world where that stuff is just taken for granted, where the conversation for most of us has moved forward to these more social questions, which are like, how can we take advantage of this new ecosystem where we have these superpowered computing agents, where we have people with real problems to solve, and where we have these systems that can be updated and modified? I want to see a very different computing ecosystem than the one we live in today, where a small number of designers in very expensive California cities make all the decisions on behalf of the rest of us. I want to see the power move back into the hands of individuals. The same way if you buy cheap furniture at IKEA, you can take it home and paint it a different color. Or you can hire an artisan to design you a beautiful piece for your front hall. I want software to have that same culture of craft, and not an exclusion to mass-produce software, but one where people can own the things that they have, where they can change them to meet their needs, whether they're personal needs for their own aesthetic preferences, whether they're organizational needs for contractual compliance, or just like business operations, and where we're not in this world where we're all beholden to a small number of big companies who own everything. So that's the dream. You know, we're embarked on this quest. We're deeply engaged in this work, and I'm really excited about all of it. And I really hope that everybody who listens to this gets a little bit of that enthusiasm and starts to ask themselves, not just like, why don't I have my data on my computer, but like, why can't I interact with computers the way they do in science fiction? Why can't I make things for myself as easily as talking about it, and where everybody has the ability to do that, whether they're software engineers or anybody else? So that's where we're going.
I certainly resonate with that vision. Like, we live in a society of walled gardens, and I want to see those walls come down, because it'd be so cool to see what what will bloom when all of that is gone, and when interoperability and local first is like the first reaction. So thanks for coming on and talking about it. It was a very fun time delving into these topics and learning more about them. So thank you again for coming on.
Hey, cool. Thanks for having me. It's been a blast.
Yeah, thanks, Peter. Ink and Switch has been, and the work and the research that y'all do has been pretty fundamental in how I've been thinking about both the software industry and like my place in it. And I've had the great pleasure of going to all the local first comps and, you know, seeing you in this pretty tight-knit community in all these spaces. And I would, again, just encourage listeners to sort of like, if this is a space that you're interested in, if these kinds of things are things you think about, definitely check out the Ink and Switch website, check out the conferences and stuff that run. There's still a lot of work to be done in the space, and y'all are doing a lot of great work. And, you know, it takes someone both putting a name to the thing that we want to build and making progress on it. So y'all are doing double duty in that regard. But yeah, I think there's still so many challenges to solve in the space, and I really just hope to see more people like chipping away at it.
Everybody's welcome. Water's warm. Come on in.